Alright, welcome to Chapter 8. We're in the last chapter of this term. Hopefully you're well on your way to getting your second math credit, and hopefully it's working out pretty well for you. I'm glad you guys are hanging with it this far, and hopefully you're just making the best out of this and trying to get as many credits as we can. So let's keep on going. Okay, this unit we're talking about systems of equations. Alright, systems of equations. And we're going to be solving them multiple different ways. So for a system of equations, what we're looking at is two or more. So two or more equations in the same variables. Most of what you're going to see, at least in this section, are x's and y's, and probably throughout most of it, because the way we learn in this section is to graph them. All right, and when we graph them, we always think of it on an xy coordinate plane. So most of our variables are going to be the x and y variables. So the solution to a system of equations is a point that I'm just going to say that makes each equation true. I'm going to say it makes both equations true. And really what we're going to be looking at today is the point that the lines meet. So this is kind of the official definition, and what we're really going to be looking at is the point where the lines intersect. Okay, so the point where the two lines intersect. It could be a bunch of lines, we don't know. We only have two for most of our work, and to be honest, the more lines that I have to try to make on there, the harder it is. It just gets really ugly. So let's go ahead and look at graphing these, and we have multiple ways that we can graph these lines. For these two, even though they're written in standard form, you can look right off the bat and say I'm going to cover up the y term, and I'll get 3x equals 4. That's going to give me a non-integer answer. So I could, if you really wanted to, I could switch it into slope-intercept form, and I think I'm actually going to do that. Again, to switch it into slope-intercept form, you're just going to solve for y. All right, so I'm going to subtract 3x from both sides, so I have 2y equals 3x plus 4, and then I divide by 2, so I get y equals 3 over 2x, and then the plus 4 turns into a, turns into a 2. Really having a hard time there. We'll do the same thing to the other one. It's not going to be much better for this one to turn into slope-intercept form, but I did it with one, I might as well do it with the other, and some people like slope-intercept form better anyways. So add the x to both sides, so x minus 5. When I divide by 3, I get 1/3 x minus 5/3. All right, it's not a great problem to really start out on, but we can understand it. We can make it work for us. So let's start with the blue one here. 3/2 x plus 2. So we start at 2. Oh, sorry, that should be a -3. Okay, that should be a -3x there, and so a -3/2 x. If you caught that, really good job. All right, remember, I make mistakes just like you guys, and sometimes I make more mistakes than you guys. It's okay. So for this one, we go down 3 and over 2, and we put another point. And I'm going to grab my ruler and at least make sure that this line's nice and straight. Okie dokie. So we get that line there, and then I'm going to graph the green or the red one. Hopefully you're not colorblind. Otherwise this color thing makes no difference to you. So I'm going to graph the red one. We start at -5/3. Okay, negative 5/3, that's like negative 1 2/3. I'm going to say that's right there. Okay? And so to figure out where those two meet, or to figure out the slope on that, I'm going to go up a whole one and over 3. 1, 2, 3. Okay, and that's going to go right through there. So when we end up drawing out these two lines, or this one also, and remember, this is kind of a, kind of a guess due to not having integer. Whoa, that was really bad. I missed that line everywhere. Let's try that one just one more time. But again, this is kind of a guess because of the fact that we didn't get whole number answers here. Or integer answers. We kind of got stuck with fractions. But I'm going to go ahead and take a stab and say that these two lines meet right at this point. Okay? It kind of looks like they do. And for today, if you're stuck with fractions that you're working with, especially fractions on the y-intercept, you can go ahead and round your intersection point up to whatever whatever's easiest. But it looks like they meet at positive 2, negative 1. So the answer here would be 2, negative 1. That would be your answer for where these two lines intersect. And that's the solution to the system of equations. I could plug in 2, negative 1 to both these equations and see that it works. Why don't we actually do that? Okay, I'm going to do it in green right here. So let's say we had 3 times 2. I'm really taking a stab here saying that this is the actual answer. Okay, I'm not going to write equals 4 yet. I'm just going to solve this out. So 3 times 2 is 6. 2 times negative 1 is negative 2. And 6 minus 2 is 4. Well, that's what it had to equal, was 4. Okay, since it equaled that, that made that one true. Now, if 2, negative 1 is the actual answer, okay, it will make the other equation true as well. It'll make the red line true as well. So let's check that. Let's use the original equation, not the one that I messed around with. So we have negative 2 plus 3 times negative 1. And I'm going to say that that equals negative 2 and plus a negative 3, so minus 3 equals negative 5. Hey, look at that. It worked. Okay, you have no idea the size of the sigh of relief I'm just letting out right now, because that was the actual answer. Okay, the lines kind of look like it, but it looked like it could be something else also. Anyways, that's what we're going to be doing. Let's go ahead and look at, again, this is just from a textbook, copy pasted into here. So solving a linear system using graph and check. You want to write each equation in its easiest form to graph. So we can do that in slope-intercept form or standard form if it works out for us. And then graph both equations, estimate the coordinates of the point of intersection, and then check the coordinates algebraically by subbing into each equation of the original linear system. A lot of words saying what we just did. Okay, you might find that this way works out pretty well. Because I think it does. Let's go ahead and look at this next one here. I'm going to use the cover-up method on this. Go ahead and cover up that. Actually, no, I'm going to turn both these into something else, because we do kind of have some ugly ugly numbers. Let's go ahead and put these in slope-intercept form. So I'll add the x to both sides, so I get 2y equals, and I'm adding x, so x plus 6. So y equals 1/2 x plus 3. If you notice, I would have had an x-intercept of like negative 6. My graph only goes to negative 5, so that's why I changed that one. And if you look at this one could be ugly anyways. But that 24, that might not fit on my graph. So let's go ahead and graph that line before we get too far into this. So positive 3. And it goes up 1 and over 2. Okay. And we got that up 1 and over 2. And we can go ahead and graph that line. So the important part on this section isn't so much the graph, it's just using the graph to estimate the coordinates and then check your work. Let's turn this one into a slope-intercept also, and we'll use a different color. Let's go with green. Okay, so I have 4y equals negative x, because I'm subtracting that x over, plus 24. And so I'm going to divide by 4. I have negative 1/4 x plus 6. That's what happens when I divide those by 4. All right, so yeah, this one didn't quite fit on my graph, but I'm going to go ahead and try to estimate where that's going to be. So my y-intercept ought to be right here. That's 6. Okay, and I go down 1 and over 4. So that's going to be right there. Hey, I think I know where these two lines intersect. That was a tough guess there. And I'm going to try not to mess everything up here with this line, but it goes right through there. So I have my two lines, and I can kind of guess where they meet. I'm going to say that they meet right here at, what's that? That's 4, 5. So again, the important part here is to plug them back in and make sure that they work. So here I'm going to have negative 4 plus 2 times 5. Remember, I don't write the equals 6. I'm going to make sure that this, as I work it out, equals 6 itself. So I have negative 4 plus 10, and that equals 6. That's good to go. And let's plug those into the other one. So I have 4 plus 4 times 5. So that's 4 plus 20 equals 24. And that's what I needed it to equal, so we're good to go. Okay, and I feel like that's a better way than saying that equals 6 and then proving that the left side equals 6 and saying that 6 equals 6, and that just, it doesn't look right to me. So that's the way that I do it. I don't have the final answer until I get all the way to the bottom. But yeah, so my answer there would be 4, 5. That's what I would put as my answer, and I make sure to write that on every graph. All right, this one, I'm going to use the cover-up method. All right, I'm going to cover up the y term. 2x equals negative 2. Okay, if 2x equals negative 2, then x equals negative 1. All right, if I cover up the x term, I have negative y equals negative 2, or y equals 2. I'm going to graph that line on there. So you can see where this method takes a little bit of time, but it's kind of nice because it's just using things that we've done before with a totally new idea. I'm going to do my second one in green again. I'll just stick to it. Okay. I'm going to use the cover-up method again, even though I know that I'm going to get an ugly answer here. I have 4x equals negative 6. So that means that x equals negative, that's 1 1/2, or negative 1.5. And here I'm going to get, we have negative y equals negative 6, so y equals 6. Yay, another one that doesn't land on the graph. But my y-intercept is 6, my x-intercept is negative 1.5. Okay, so that's about there. And let's see what happens if we graph that line. And there we go. So what I like to do, and this is why it's a graph and check method, is because I don't really think they meet at this point, but I really think that if they are off, it's due to, number one, I'm having to deal with a number that's not on my graph, and I'm having to deal with working with halves. Okay, so I'm going to say that this is at negative 2, negative 2. I'm going to check that. That's my guess right now. Let's go and check that. So 2 times negative 2 minus a negative 2 equals 2 times negative 2 is negative 4, minus a negative is plus 2. So that gives me a negative 2 there, and that's what I needed. Let's do that for the next one. 4 times negative 2 minus a negative 2 equals negative 8 plus 2, which is negative 6, and that's what I needed there. So they worked out everything's good in the end. My answer is -2, -2. You should always write your answer in the form of a point. Turn the page. Let's move on. Let's look at a couple more, and then you'll get a chance to do some. Let me get all this straight here. We're almost done here. That's pretty cool. All right. Oh, these are some weird looking equations. Look at that. Y equals -3. Well, where on earth is y equal to -3? Well, this is the y-axis, and there's -3, so maybe it's right there. All right. Then on this one, where is x equal to 4? Well, x is equal to 4 right there, and all these vertical points through here. And what point do you think those two meet at? I bet those two equations are going to come in handy. X is 4 and y is -3. That's just what these told me. Okay. So let's go ahead and look at what our answers, or let's go ahead and check our answer. So for the first one, I can't plug in an x value, but I can plug in -3 for y. Well, -3 equals -3. That was really hard to check. And for the next one, my x coordinate is 4. Well, 4 equals 4. There you go. A really tough one there, but still an important one to do nonetheless. All right, let's look at these next couple and see what we got. For the top one here, it's in slope-intercept form. I really love that. So I have a y-intercept at 2, and it goes down 2 and over 1. And I can go ahead and graph that line. I think I'm going to show you a trick on this one, if it sets itself up to do so. Whoop. Kind of missed that line a little bit, but oh well. Should work out for us. And let's look at this second equation at -3. And it goes down 1 and over 3. Is that right? Yeah, it's -1/3 x. It sure does. So down 1 and over 3. Okay. So we can go ahead and graph that. And it looks like they meet at a pretty tricky point. But I'm going to show you a little, not really a cheating way, but a way to get a different look at these. So if you run into an issue where they don't meet at a great spot, they kind of meet in the middle of this here, I'm just going to double check with my slope on this line. And I'm going to say I went down 2 and over 1. Yes, I did. That's what I was supposed to do. Let me just double check it. Down 2 and over 1. Well, already this line should have been through this point, and it's not. Okay, and it's just because I'm slightly off up here. And when you're slightly off somewhere close, the farther and farther you get away, the more it gets off. So then from here I could go down 2 and over 1 again, and I would actually be on this point. So this blue line should actually be through that point right there. So the blue line should look more like that red line. So that's kind of why it's a graph and check. You definitely want to look at what you're doing and make sure it makes sense. Okay, but if you want to, you can start at your y-intercept and just take your steps out with your slope and maybe see if one of those points doesn't intersect the other line. Okay, that's kind of an easier way to do that sometimes. But this meets at 3, -4. That's my guess. Let's go ahead and check it. So y coordinate of -4. I'm going to go ahead and write it this way. It's okay to do it this way in slope-intercept form because we're on different sides here. Our variables are on different sides. -2 times 3 plus 2. So does -4 equal, and remember this is a question, does -4 equal, that's -6 plus 2. And yeah, -4 equals -4. So we're good to go there. Let's test the other one. -4 equals -1/3 times 3 minus 3. A lot of threes going on there. So -1/3 times 3 would be -1 minus 3, and that does equal -4. So that's good to go as well. All right, so my answer, again, 3 -4. And it works. That's pretty cool. All right, I want you to pause the video and try the next two. Welcome back. Hopefully you got a chance to get those done. Let's at least work through one of these, and then if we have to, if we're running out of time, we can kind of fast track through the other one. But let's go ahead and use the cover-up method on this first one. So I get an x-intercept of 2. 3 or 6 divided by 3 is 2. And a y-intercept of -3, because 6 divided by -2 is -3. So then after that we can graph that line. Try to be a little bit clearer on that. I'll tell you, that's the one problem with graphing, is just being off a little bit. If your graph meets somewhere out towards the edge, it can really cause you problems. I even see right now that line's a little too far below that intersection point. Okay, but hopefully it doesn't bother us too much. Let's go ahead and see. So I have x equals -2 on this one. So x equals -2, and -2y equals -2. That means y equals 1. Is that right? Yeah, y equals 1. So let's see what happens when we draw these two lines. And we'll go ahead and graph it right there. Really helps to have a ruler, and if you don't have one, remember you can always make one out of a piece of paper. All right, I would say that they probably meet right here, and that's the point 4, 3. And we can go ahead and check that. 3 times 4 minus 2 times 3. So that's going to be 12 minus 6 equals 6. That's what we needed. And 4 minus 2 times 3 is 4 minus 6, which is -2. That's what we needed there also. All right, last one. We're going to go ahead and get through this real quick. You should have got that these two lines intersect at 2, 2. Okay, you've got one line that's kind of goes up through here. Oop. So our rulers are kind of nice. And then another line that comes through here. With these two lines meeting at 2, 2. And so you get 2 equals -1/2 times 2 plus 3. So 2 equals, that's going to be a -1 plus 3. And so 2 equals 2. And then for the other one, 2 equals 2. There's a lot of 2's in this one. So 2 equals 2 times 2 minus 2. Is that true? 2 times 2 is 4. Minus 2 equals 2. So there we go. All right. Now that we've got those done, I want you guys to go ahead and try the practice mastery challenge, or practice application mastery challenge, and good luck out there. We'll see what I think are the top 5 NCAA basketball tournament buzzer beaters, and that just being a shot at the end of the game that wins the game, or in order for it to be a buzzer beater, you'd have to win the game. So let's go ahead and look at what number 5 would be. Number 5 is James Forrest, and this is in the Georgia Tech USC game in 1992. And basically what you're going to see here is Georgia Tech is a number 7 seed and USC is a number 2 seed. And there's 0.8 seconds on the clock once we catch up with the game. And the Georgia Tech is down by 1 point. And let's go and see what happens.
Timeout that they shouldn't have it. It should be a technical.
They just got to throw it under the basket. Under the basket. Up.
Forrest shot.